The goal of this video is to observe the effect of spin or angular velocity on a ball being dropped from the top of a silo. The silo was 80 feet in height, a vertical drop that may be sufficient enough for us to observe the Magnus Effect. When a ball was dropped from the top of the silo, the ball fell straight down. But when the backspin is applied to the ball does not appear to drop straight down. From the side view, this appears more distinct. The ball lands farther away from the silo when dropped with spin than without. When the side view is overlaid with a grid, the path of the ball can be graphed in a 2D plane as a second-degree polynomial function. Here's a physics illustration for the Magnus Effect. In the first image, you will see the ball is tossed straight off the top of the silo. The ball falls directly down with the wind opposing the vertical drop. Note that the ball causes a deviation in the wind path. Now the ball is dropped with a backspin, which has an angular velocity. As the ball is dropped with an angular velocity, some of the wind deviates in the same direction as the angular velocity. The wind on the top half of the ball, moving with the direction of the spin, will be deflected around the ball and back, as shown by the F arrow. Wind coming from the opposite side of the ball, moving against angular velocity, is separated away from the ball and a gap is created. The ball is forcing the wind in the left horizontal direction in this illustration, and the ball opposes this force by applying a normal force in the opposite horizontal direction. The ball will move horizontally in the direction of the normal force as well as vertically due to gravity. The Magnus effect can be quantified by finding the Magnus force vector. The Magnus force vector is equal to the cross product of the angular velocity of the object and the velocity of the fluid or object, this all multiplied by the air resistant coefficient across the surface of the object. The Magnus effect applies to all rotating balls and discs and has industrial and athletic applications. One example of an athletic application is the bending of a soccer ball. Soccer balls are often intentionally subject to an angular velocity when kicked. The ball will have both a side and a top spin to provide curvature and drop to elude players. Special thanks goes to Dale Martin for use of his silo, and Dr. Daniel King. This video was inspired by Veritasium YouTube channel created by Derek Mueller.